In this video, we are going to uh, talk about an application of linear functions and learn how to build linear models from verbal descriptions. Many real-life situations can be modeled using linear functions, and this is one example. In this scenario, an appliance repairman charges a 75% service fee plus $90 an hour. In other words, this repairman will charge you $75 just to show up at his door, and then on top of that, he will charge you $90 for every hour. So let's create a function f of t that gives the total charge f of t given the number of hours spent fixing the appliance. All right, so f of t will be equal to, well, no matter what, you are going to be charged $75. So we're going to start with that. And then on top of that, you have to add $90 for every hour that is spent fixing the appliance. So you're going to do plus 90 times t. Now, this is a perfectly fine answer, but often we like to make our functions look a little bit more like our general form, which is y equals mx, or f of x equals mx plus b. So we're going to put the term that has a variable first. So we'll have 90t plus 75. And this is a this function, you can plug in however many hours the repairman spent fixing your appliance. That will be the cost if you plug it into this function. Next, we're going to graph f of t. One issue is we have fairly large numbers here, so we're going to want to be mindful of how we are going to label our axes. Let's start, though, by identifying what the slope and y-intercept is. The slope, or m, is equal to 90 in this scenario, because that is what's multiplying by the variable. And the y-intercept, or b, will be equal to 75. So if I graph this, maybe I'll do it down here. Try to make it fairly big. And we'll do 1, 2, 3, 4, and maybe we'll go up by 10. So this would be 10, 20, 30, 40, 50, and maybe I'll skip this, so I'll just do every 50. So this would be 60, 70, 80, 90, 100 would be here. 110, 120, 130, 140, 150 will be here. And I think that should be fairly decent. I think that'll be good enough. All right. So let's graph our function. So our y-intercept is at 75. So this one would be 60, 70 and a half. So that will go right here. That's our y-intercept. Nope, that's the wrong place. So 50, 60, 70, and then the 75 will be here. Sorry, it's deleting itself for some reason. There we go. And so that's the point 0, 75. And my suggestion in this case, to be honest, I wouldn't use slope because, well, I guess you could go up and over 1. I would just keep adding 90 for every hour. So my next hour would be at 165, which would be somewhere up here. So there's 60, there's 65. And so that goes here. I am wondering if it might be a little bit better to change because right away I'm running out of space. I only have 2 points on here. So I might change my X, my Y, what do you call it? I'm going to change the scale on the Y-axis. And maybe I will make everything 25. So this will be 25, 50, 75, 100. And so the next one would be 125, 150, 175, 200. Go up 4 more, so 25, 50, 75, 300. 325, 350, 375, 400. This might be a little bit better. So first, my y-intercept is still at 75, which is down here. When I add 90 to that, that would be 165. So here's 150. It'll be a little bit above that, probably about here. So that's after 1 hour. So 75 plus 90 was 165. 165 plus 90 is going to be 255. So 250 is right here. I'll go a little bit above 250, maybe right about there. So 255 plus 90 is equal to 345. So I'm going to find 350 and go a little below that. So 350 would be here. I go a little bit below that. And by the way, I noticed that I mislabeled my x-axis, so I'm going to change that so it's correct. And then, well, I guess we can do one more, which would be 345 plus 90 would be about 435. Now 435, this right here is 425, so I go a little bit above that, maybe right about there. Draw my straight line. Okay, so there is a graph of how much you are getting charged if you hire this appliance repairman. All right, what is the domain of f? Now, normally for a linear function, the domain would be all real numbers, but you have to be careful because this is a real life situation. It is not possible that the appliance repairman shows up and spends -1 hours fixing your appliance, for example. And in fact, he couldn't fix your appliance in 0 hours. Now, if he's really fast, maybe he could get it done in, almost immediately, maybe in 1 second, if he's really good. So we'll say that the smallest possible number is 0, but it can't be equal to 0. That would be my thought. Now, how many hours could he take? It could take any amount. It could be maybe, like I said, 1 second. It could be half of an hour. It could be a full hour. It could be 3 hours. It could be 10 hours. Now, realistically, it probably won't be 1 million hours, but we'll just assume it could be as large of a number as you would like, and maybe if it takes an extra long time, maybe the repairman's son takes over after he passes away, and he can take as long as he wants to fix your washer dryer. So we'll say that the domain is equal to is in between 0 and infinity. In other words, it's any positive number could be entered into this. All right, next question. If it took the appliance repairman 3 hours to fix the dishwasher, what would be the total charge? Well, let's start with our formula. I'm going to zoom in a little bit, which is 90 times t plus 75, and we are going to plug in 3. So this would be 90 times 3 plus 75, which is 270 plus 75, which is equal to about 345. So it would cost $345 if it took him 3 hours. Okay? One thing I want to point out, that point right here represents this scenario. If it takes 3 hours, the input is 3, then the output is 345. So you could have also used your graph to figure that out. All right, let's pretend that the repairman, that someone was charged $210 for the repair. And we want to know, how long did it take the repairman to fix the appliance? In other words, in this case, we know what the output is, and we're trying to figure out what the input is. So how do we do a problem like this? Well, the output is f of t, so we replace f of t with what it's equal to, so it's $210. And we keep t, and we are going to solve for t. So I'm going to subtract 75 from both sides. 210 minus 75 is 135. And I'm going to divide both sides by 90. And that means that t is equal to 135 divided by 90, which is 1.5. So it took the repairman 1.5 hours we'll just say 1.5 hours to fix the appliance. Okay? All right, and so we are done with this example. I hope this video was helpful, and we will see you in the next video.